And we're going to go ahead and get out and get our PowerPoint presentation pulled up this morning for everyone. So I'll be sharing my screen. And Tony, as usual, if you'll please kind of be the scribe and watch that chat box in case we have any questions. And fellas, we'd ask that you please ask those good questions. Don't be shy. In other words, if you've got a question as we go through our training today, let's be sure and get those questions asked as we go through our training. Okay. So let me get my screen going here. And Tony, you'll please let me know if everything looks good on the screen here once we get her pulled up. So we should be on that front screen.
Yeah, looks good, Joe.
Okay,
yep.
That sounds good. Well, fellas, as you can see, our HMH7 heat pump, the product actually comes in two footprints. We have a 2-fan model, which is going to be the 4 and 5 ton model, and we have the single fan model, which is going to be the 2 and 3 ton model. And so I'm going to go ahead and also real quick, I'm going to go ahead and shut my camera off real quick, fellows, because it seems to stream a little bit better whenever I shut my camera off. So we're going to shut my camera off real quick as we move forward. Guys, we'd also ask that you please remember the unit service fittings are 5/16 fittings. They're a flare fitting, and you're going to need an adapter that's going to allow you to go from your 5/16 fitting on the unit down to your 1/4 inch service hose fitting. And so these adapters, they look a lot like what's on a mini split, even though this is not a mini split, and we want to stress that this is not a mini split. It still looks like one, and it uses the same type of hose adapter for your service hoses. And, you know, Robin Air, Yellow Jacket, there's a lot of manufacturers that make these fittings. You probably have some on your truck already, but just please remember you need to use that service fitting to get your service hoses onto the outdoor unit. Some of the questions that we get asked quite often, actually, on the unit as well, is you know, we'll be asked, you know, what temperatures will this thing operate at? So depending on what area of the country you're in, you know, this little chart, I went ahead and included this. This is in the install information. And this is just the basic parameters, the minimum and maximum parameters for outdoor and indoor coil temperatures. As you can see, the outdoor coil in the cooling mode of operation, minimum is actually 35 degrees and maximum is 122, which is a pretty broad range. And in the heating mode of operation, -5 is what they'll operate down to. And then in the heating mode, up to 75 degrees outdoor air temperature. Now, Tony, a little bit later on, either in the program, we can let him share his screen, or he'll be glad to give you some information. We have some expanded numbers as well. I know some of our customers have asked about some expanded numbers and ratings and stuff like that. And towards the end of the program, we'll let him address that if that's something that you'd like to know a little bit more about. He's got a nice little chart that he's populated, and that shows some expanded ratings that we can certainly discuss in our question and answer session a little bit later on. So at this time, we're going to be discussing the low voltage wiring and the setup of the outdoor unit with an AE air handler. And remember, please, the AE air handler features a standard ECM motor. Now, when we talk about a standard ECM motor, we're talking about that high efficiency motor that has the 5 speed taps on it that you can actually select a speed tap on it. So we're going to talk about the low voltage wiring and a simplified block wiring diagram. Now remember, the AE air handler has no physical hard screw terminals, but is equipped with pigtail connections. And the fact that you guys have put a few of these in before, you know that you do have to have an accessory single pole double throw relay in the indoor unit, and we're going to use that for airflow reduction. And that kit number HMH7AK001 is recommended for convenience and the supplied parts. Now, what we mean by supplied parts, it actually comes with a control board with a little, you know, with a little relay mounted on the board. It also has a biflow filter dryer, as well as some harnessing that comes in there that makes it convenient to hook all the wires up, the field wires up. So we're going to definitely recommend that HMH7001 kit. However, I have had some questions from contractors, some that have called in, you know, from the field and said, hey, I don't have that kit. I've got this unit. can I make up my own kit? In other words, can I use my own single pole double throw relay with a 24-volt coil? And the answer is, of course you can. Can I put my own bi-flow filter dryer in there? Well, sure you can. And can I make up all my own field wiring with just low voltage wiring? And the answer is absolutely, of course you can. But for convenience and supplied parts, we do like this kit. But just know this, that if you just have a little peanut relay, 24-volt coil, and your own bi-flow filter dryer, you can still make this thing work perfectly fine by supplying your own parts if you need to. In addition, we're going to ask that you please remember your heat pump thermostat needs to be just a conventional, your favorite heat pump thermostat on the wall. However, make sure that your heat pump thermostat has a BO selection for reversing valve operation, because our HMH7, unlike our other Champion product, it utilizes the B terminal in the heating mode of operation instead of the O terminal for cooling mode. So please keep that in mind as we go through and we talk about the product, that it uses the B terminal for heating and then not the O terminal for cooling like on our other products. It's not bad, it's just different. So please keep that in mind. Any questions or comments so far before we get jumped into some of those, before we jump into some of those simplified block wiring diagrams?
Check that it is being right. I think we're good, Joel.
Everybody good? Okay, well, sounds good. Well, fellas, what we're going to do, we're going to start out with an AE air handler. And again, we're going to go wire for wire, and we're going to just presume that you have a two-stage heat strip in this air handler. Now, if it turns out that you only have a single-stage heat strip, you just wouldn't have that W2 input on the thing. So basically, we're going to take this wire for wire, and please ask those good questions as we walk through, going from the thermostat to the indoor unit to the outdoor unit in this overview. So B terminal, again, is going to go outside from the thermostat to outside for reversing valve operation in the heating mode of operation. And remember, please, your thermostat has to have a selection so that you can select that B for heating on the outdoor unit. W2 will be our second stage auxiliary heat if it's so equipped. If you have a real small home or a real small air handler, you may only have a single stage heat strip in there, but if you have more than one stage of heat strip, W2 will be your second stage auxiliary heat. W1 we're going to carry all the way through from the indoor unit to the outdoor unit and the thermostat. That's going to be our first stage auxiliary heat. In addition, we're going to bring that W wire from the outdoor unit inside to W1 on our indoor unit, and that's going to energize those heat strips during defrost. So we always want to remember to bring that W in from the outdoor unit to the indoor unit so that we can have some auxiliary heat during defrost, because as you guys know, that when you go into defrost mode of operation in the heating mode, when you go to defrost operation, what's going to happen, you're going to actually go into the air conditioning mode. And we want to make sure and bring some heat strip on or some auxiliary heat so we don't freeze the homeowner out during the defrost cycle in the wintertime. Y terminal is going to be our compressor call from the thermostat to the outdoor unit. Now you're going to please note something. You may have a factory wire on your ECM motor, a yellow wire. It may be equipped, your air handler may be equipped with a yellow wire on the ECM motor. Go ahead and remove that yellow wire on the ECM motor, because we're going to configure that motor with our own inputs, if you will, from the relay and so on. So if you do have a pre-wired ECM motor with a yellow wire on it, go ahead and remove that, because we'll be doing some other low voltage wiring here shortly with the motor. B is 24-volt common, and we're going to carry that all the way through from the thermostat to the indoor unit to the outdoor unit. 24-volt common. Our terminal is going to be 24-volt hot, and that will go from the thermostat to the indoor unit. Now, please note it does not go outside. We don't have that R terminal going all the way through outside. Guys, I'm going to ask at this time that you go ahead and mute your microphones, if you would, because I'm getting some background or some sort of feedback from. There you go. Whatever that was. Thank you. Okay, we're squared away. So that 24-volt hot, that R terminal again does not go to the outdoor unit. And then G terminal is going to be our low speed on the ECM motor. So typically what you'll do is you'll just select low speed tap on the ECM motor for your G call. And that's very, very typical. That's normally how most contractors wire this up. So if the homeowner goes to the thermostat sub-base assembly and they want to just circulate air, the unit's not calling for operation. We just want to keep air moving in the house across the air filters and so on. G, you just have a G call, in other words. We normally recommend just have that on the lowest speed tap for that. Any questions or comments before we start getting into wiring the ECM motor and talking about that relay? Any questions or comments? Everybody good?
I think we're all right, Joe.
Okay, sounds good. Okay, so from the relay, one side of that relay coil, we're going to go up and we're going to hit S1 outside. Now, that S1 is going to be a 24-volt output from the outdoor unit to energize that relay to reduce airflow. So when we get an S1 output from the outdoor unit, we're actually asking the indoor unit to reduce airflow. And that's what that relay is all about, is an airflow reduction relay. The other side of that relay coil is going to go to common, and that'll complete our coil circuit or control circuit on that relay. On the switching contacts of the relay, the common terminal on the relay of the switching contacts, we're going to go grab that yellow wire or that compressor. Whenever we call for a compressor operation, we're going to have power up to the common switching terminal or the common point of the switching terminals anytime we have compressor operation. Now on the ECM motor, we're going to recommend that you go ahead and take a wire from W1, which is going to be our auxiliary heat call. So anytime we get an auxiliary heat call, we're going to drive that indoor motor to high speed. And that's, again, very typical. We want to make sure that we've got plenty of airflow across that heat strip. Anytime we get a call for either defrost operation or anytime we get an auxiliary heat call, we want to drive that ECM motor to high speed. On the normally closed contact of the relay, we're going to come over and we're going to grab a speed tap. It's going to give us 100% cooling airflow. Now, guys, please remember, on the air handler, you're going to have multiple speed taps on there. And so you're going to have to select, you're going to need to select a speed tap on the normally closed contact of that relay. It's going to give you 100% cooling airflow. Now, we always recommend that you set your airflow up for 400 CFM per ton of cooling capacity. So if I've got a 2-ton unit sitting outside, I'm going to need 800 CFM on that 100% cooling airflow call on that normally closed contact. If I've got a 3-ton unit outside, I need 1200 CFM and so on. So just plan on 400 CFM per ton or get as close as you can to it on that normally closed contact on that relay. The normally open contact of the relay, we want you to be around 60% airflow. And so that's the whole idea of the airflow reduction on the relay. So on the normally open contact, about 60% airflow on that relay. So here's how this works, and we'll show you a little animation here. We'll switch that relay here for you in a little bit, but here's the idea. When the outdoor unit gets down to about 60% modulation, 60 to 65% modulation, it's going to generate an S1 signal, a 24-volt signal on S1. It's going to switch that relay and command a lower airflow inside. And so that's going to provide better humidity control, better comfort, quieter operation, and so on. So really what we're doing, we've got a very, very high-tech outdoor unit, but we've simplified the low voltage wiring on the thing to just use a conventional thermostat. This is a non-communicating system and just a conventional heat pump thermostat. And you're going to notice, just count the wires outside. You've only got 5 wires going outside for all this function. So in the outdoor unit, it'll modulate from 35 to 100% capacity. But once that unit outside hits about 60% capacity, it's going to generate an S1 signal, 24-volt signal. It's going to switch that relay and command a lower airflow to help better match the airflow to the capacity of the outdoor unit. Any questions or comments before we give you a little animation on that relay and watch it switch, and as we talk a little bit about that reduced airflow. Any questions or comments on the basic block wiring diagram so far? Everybody good?
Everybody seems good.
Okay, so as we take a look at this, watch the animation. You'll see that, let me do that one more time. So as we animate this thing and we click it, we see that we get an S1 when that outdoor unit hits about 60% airflow. It's going to generate an S1 signal, switch that relay, and command low airflow or lower airflow on that ECM motor on the normally open contacts, which are now going to be closed when we switch that relay. And you'll please notice that that outdoor unit's going to do that when it hits that lower point of capacity. One thing we would like everyone to please keep in mind that if you do get a W1 call, anytime you get a W1 call, you're going to drive that fan to high speed, and S1 will have no effect at that point. Because remember, on an ECM motor, if I have more than one speed command on an ECM motor, it's going to automatically always go to the highest speed command that's being commanded on that motor. So if I have 2 or 3 inputs on an ECM motor, it will just automatically take the highest speed command that it gets. In addition, please remember, W1 will be present with a thermostat auxiliary heat call or one more time during the defrost cycle. So that's basically how we wire up the unit with an AE air handler. And please remember that AE air handler just does have pigtails. Now on a furnace, when we do dual fuel, which we'll talk about here shortly, when we do dual fuel, your furnace is actually going to have some hard physical screw terminals that you'll make on there. And so we'll talk about that here shortly as well. Any questions or comments on an AE air handler and how we've applied that HMH7AK001 relay kit and how we wired the thing up as far as for airflow reduction and all the features? Any questions on that? Okay. All right, so let's go ahead and take a look at this time. We're going to again talk about some low voltage wiring and setup with our heat pump on a TME furnace, which is a single stage high efficiency motor, and a TMY furnace, which is a high efficiency standard ECM motor, and a 2-stage heat furnace. Now, please remember the TME and the TMY furnaces, when we do the simplified block wiring diagram, just please remember that the TME is a single stage and the TMY is a 2-stage furnace. Now, we're still going to use that single pole double throw HMH7AK001 relay kit, just like we did before. Now, one of the things we have to always remember too, guys, is because we are doing a dual fuel application, we're going to have a heat pump thermostat that's going to have that VO selection, just like we had before for the reversing valve. But also, please select a heat pump with a dual fuel function, because on the furnace product, we're going to have the dual fuel function. And by the way, our outdoor unit is not designed to have an integrated dual fuel setup. So you're going to have a heat pump thermostat with a dual fuel function, which means you're probably going to have an outdoor sensor, or you're going to have some sort of Wi-Fi hookup on your heat pump thermostat so it can do a dual fuel changeover for the furnace. But just please remember that heat pump thermostat with dual fuel function anytime we're hooking it up to a furnace product for dual fuel or hybrid type of situation. So let's take a look at this. Now, this is going to look very familiar to you because this is essentially what we did before. But now remember, the TME furnace is a single stage furnace with just a single W input on the furnace. But just like we did before, we'll breeze through this fairly quickly, I'm sure, because it looks real familiar to it like an AE air handler. It's just that the terminals are a little bit different. And we do have hard screw terminals, by the way, as I mentioned on the furnace. So B terminal is going to go all the way through just like before. W1 on the thermostat will go to W, just W, because it's a single stage furnace, just W on the furnace, and then W outside for our defrost cycle. So whenever we go to defrost, we're going to want to bring on auxiliary heat. We want to bring the furnace on during defrost so that we can have some auxiliary heat during the defrost cycle. And then Y terminal will go outside just like we did before. C will be our 24-volt common. Again, this looks real familiar because it's essentially the same wiring we did on an AE air handler. It's just the terminals, again, are a little bit different. Our terminals are 24-volt hot. It does not go outside, which I think is kind of cool, actually, the fact that we don't need to take that outside to power up the board outside. The outdoor unit has its own source, and it's just looking for inputs from the thermostat on B, W, Y, and C, as you can take a look on that. And then G terminal will be going from the thermostat to the indoor product. Now, as we wire this thing up, again, it's going to look real familiar to you. S1 will be going to one side of our relay coil, our control voltage on the relay. The other side of the coil will be going to common, which will complete our coil circuit. Our 24-volt input on the switching contact common terminal will be coming from the compressor collar, the Y signal. Our normally closed contact on the furnace, it'll be designated Y/Y2. So we'll have normally closed will go up to Y/Y2, and then normally open will go up to Y1 on the furnace. Now, one of the things I like to kind of point out about our TME furnace, which I really like, is the fact that even though it's a single stage heat furnace, even though it's single stage heating, that board is actually two-stage cooling capable, and a lot of our customers didn't know that. They didn't realize that we had two-stage cooling capability on our single-stage furnace, which I think is a pretty neat feature because, quite frankly, you know, that gives you a very, very versatile product. I really like the TME furnace. It's just a simple little furnace, but it does have two-stage cooling capability, which I think is pretty cool. No pun intended, but I guess kind of intended. So any questions or comments on wiring up or the simplified block wiring diagram with our TME single stage furnace and a dual fuel application? Everybody good? Okay. Well, fellas, let's go ahead and keep that exact same low voltage block wiring diagram. Nothing, I mean, everything wires up exactly the same as far as common and red and the relay. Everything stays the same on the TMY two-stage furnace. The only difference is you're going to notice the TMY furnace, the low voltage wiring, everything wires exactly the same, except the TMY is a two-stage furnace and requires a W2 input. And the W/W1 terminals are just labeled a little bit differently. So you'll see that we have like a W/W1 and then a W2 because it's a two-stage furnace, but everything else wires exactly the same. So let's go ahead and do that. W2 will go from the thermostat to the furnace, W2 to W2, and then W1 will go to W/W1 on the furnace. It's labeled W/W1, and then that'll go outside to the outdoor unit for our defrost. Whenever we go into defrost, we'll bring in the first stage of heat. So as we take a look at this and we animate it, we notice it's the same type of animation we had before. S1 will energize that relay. It'll switch for reduced airflow anytime we hit that point of capacity outside. When we hit about 60% capacity outside, it's going to switch that relay and command low airflow on the indoor unit, matching to more closely match the capacity of the outdoor unit. And again, that Y1 call should be set up, or if you take a look at your control board, it'll say low cool, and that low cool speed tap should be selected to give you about 60% airflow on Y1 and 100% cooling airflow on Y/Y2. So any questions or comments on wiring up these furnaces? Again, it's very similar to what we had in our previous slides, but we're going to be talking about some variable speed product now, some variable speed product here shortly, as far as a air handler and a variable speed furnace. And then we'll talk a little bit about some airflow considerations as we kind of wind up the training for the morning. But any questions or comments on our standard ECM motor furnaces at this time? Everybody good? Okay. Well, as at this time, we are going to talk about low voltage wiring with a variable speed air handler and a variable speed furnace. And again, the wiring is going to be very, very similar. The terminals will look a little bit different, but basically it's going to be just a simplified block wiring diagram that we'll discuss at this time. Now, one of the big things we want to remember on any variable speed product, can't say it enough, you're going to have the 002 kit, the HMH7AK 002 kit. Now, that kit comes with 2 relays. Let me say that one more time. The kit comes with 2 relays, and they're going to be designated the RV and the S1 relay. Now, again, we're going to recommend this kit for convenience and supplied parts. But please remember, guys, if you've got a unit and you don't have the kit, you could still use, you could still have just 2 relays that you could take off your truck stock, if you will, just a couple peanut relays. I had a question the other day from a contractor. He didn't have a 002 kit, but he had 2 001 kits. Can you use it? And the answer is absolutely. So basically you just need 2 relays on the variable speed product, and we'll show you why as we talk through that a little bit. But so if you were in a jam and you didn't have the 002 kit, you could use 2 001 kits and have the same function. You just wire them up in such a way that you'd have the RV relay and board and the S1 relay, which we'll show you here in a second or two. Now, guys, please remember you're still going to use a heat pump thermostat with that BO selection for reversing valve operation. And anytime you have a heat pump hooked up to a furnace, you're going to want to have a dual fuel capable thermostat on any of our furnace product. Let's take a look at that. There's those 2 relays there. So we have 2 relays. One of them is the RV relay. One of them is the S1 relay. The S1 relay will be for airflow reduction. The RV relay will be for some other advanced functions on the O terminal, which we'll discuss here shortly. But just like before, this looks real familiar to you guys. It's going to be the same type of wiring that we had before. B is going to go for reversing valve operation in the heating mode of operation. W2 and W1 will be hooked up just like we had before. W2 second stage heat, W1 first stage heat. Your Y terminals for your compressor call is going to go outside just like we did before, is common, and 24 volt hot is going to be the same. And remember, guys, that 24 volt hot does not go outside, but this all looks real familiar to you because it wires the same even on a variable speed product. And then your G terminal will go from thermostat to the indoor product. Now, guys, as we start getting into wiring up our S1 relay and our RV relay, you'll notice that both sides of both relay coils are going to go to common. So we're going to have to have that for both relay coils. In addition, you're going to notice that the other side of the S1 relay is going to go to S1 outside, just like you had before. And by the way, while I'm thinking along this line of thinking, look at this. Even on a variable speed product, our best indoor unit that we've got, variable speed air handler, variable speed furnace, look at the number of wires going outside. We still only have 5 wires going outside to the outdoor unit for full function. And so I think that's really neat about the HMH7. It doesn't matter if you're hooked up to just a simple little AE air handler, or if you're hooking up to a full-blown variable speed product inside, you still only have those 5 wires outside. And I think that's really neat because that gives us a lot of versatility and tremendous application flexibility in the fact that we can take this HMH7 and literally hook it up with anything in our inventory except our 21 SEER products, that are fully communicating only products. So that's, to me, that's a pretty neat application. It gives you lots of application flexibility, literally from our simplest air handler to our most advanced variable speed indoor product. You'll notice that on the S1 relay, just like we had before. We're going to take 24 volts from our Y signal for our compressor operation outside and take it to the common terminal of our switching contacts. Normally closed on that S1 relay will go to Y/Y2 for our high-speed airflow. Normally open will go to Y1. Now, where some of the questions I start getting on is that RV relay. Why is that RV relay necessary? So let's go ahead and start talking about the RV relay. So we're going to take the other side of the RV relay coil. One side went to common. The other side is going to go up and go to the B terminal, And so what's going to happen is the B terminal, anytime we go into the heating mode of operation, we're going to energize the RV relay. So take a look at that wiring diagram again. As we energize the B terminal for heating mode of operation, we're going to switch the RV relay. And let me show you why that's important. So we're going to take 24 volt common from the Y terminal. In other words, anytime the compressor is running, we're going to have 24 volts to the RV relay common terminal of the switching contacts. The normally closed contact on the RV relay is going to go up to O terminal on the variable speed product. Now, this is important because our champion variable speed products, it doesn't matter if it's a variable speed air handler or variable speed furnace, it has to see O terminal in the cooling mode for some advanced functions. Now, if you take a look at your variable speed control boards on a furnace or an air handler, either one, you're going to have some airflow settings and airflow jumpers. And so those airflow jumpers are going to be set up in such a way that you can actually have some what we call delayed cooling functions that will give you a ramping operation on the fan, depending on what the geography that you live in the United States. To give an example, in Mobile, Alabama, where I've lived for years, there's a humid profile. So there's 4 profiles, there's 4 cooling delay profiles on the control board of the variable speed product. Well, I just happen to remember that, B terminal or B jumper on the cooling delay is for a humid profile. So what happens is that when you're in the cooling mode of operation, and the board knows that you're in the cooling mode of operation, and you have it set on that humid profile, what'll happen anytime you get a call for cooling, that fan will start out real slow, like at 50% airflow for like a minute and a half. And then after about a minute and a half, it'll ramp up to 80% or 82% airflow, and it'll hold that airflow for like 6 more minutes. And then if the call for cooling is still there, it'll ramp on up to 100% airflow if the call for cooling is still there. So this cooling on delay ramping profile is actually driven by that O signal. So in other words, the indoor unit has to know that that heat pump is in the cooling mode of operation for some of those advanced fan functions. In the heating mode of operation, you disable that O terminal. And so what the RV relay does, the only thing the RV relay does is it energizes the O terminal and tells the indoor unit that, hey, I'm in the cooling mode of operation. And then when I go into the heating mode of operation, I'm going to energize that relay and I'm going to break that O terminal in the heating mode. So the indoor product, it's designed to have some advanced functions, but it looks at that O terminal on a heat pump. It looks at that O terminal for some of those advanced functions. Now we're going to show you guys, we're going to animate these relays here in a little while after we talk about some low voltage wiring, a little bit more low voltage wiring on the variable speed furnace. And we'll animate those relays so you can kind of visualize how they're working. But any questions or comments on why we would have a separate relay for the RV relay or a separate relay to energize the O terminal, and more specifically to de-energize the O terminal in the heating mode on our heat pump application for the indoor product. Any questions or comments on that? So in summary, the RV relay, its total function is to de-energize the O terminal in the heating mode of operation. Okay. At this time, we're going to talk about the TMV two-stage furnace. I'd like everyone to note that the low voltage wiring and the relays wire exactly alike. The only difference is the air handler and the TMV furnace, the heating terminals or the terminals are labeled slightly differently. And so, but as far as the low voltage wiring, it wires exactly the same. You'll just notice that the terminals are labeled a little bit different on the furnace. They have like a W2/, and then they have like a W/W1 and then a W2. But other than that, everything wires exactly the same between the two variable speed products. So as we take a look at that animation, let's look at what happens when we do our animation. You'll notice right there on the S1, let me do it one more time. When we have an S1 output from the outdoor unit, just like before, we're going to switch the S1 relay, and we're going to command low airflow on the indoor unit, Y1 airflow. We're going to command Y1 airflow for reduced capacity when we're in reduced capacity outside. Now watch the RV relay. The RV relay, let me do it one more time. When we energize the B terminal in the heating mode of operation, we're going to energize that RV relay, and we're going to switch it. And when we switch the RV relay, we're going to break the O terminal in the heating mode. That's the only reason that RV relay is there, is to break the O terminal. Watch that animation one more time. We're going to break that O terminal right there in the heating mode of operation, and tell the indoor unit that basically now we're in the heating mode of operation, and to ignore that O signal because it's no longer present. So any questions or comments on the relay logic and the relay function that we have on any of our products, but specific to the variable speed indoor product, it's a little bit different than our single stage products and so on, ECM motor products. But any questions or comments on the relay logic and how it's working on our variable speed products and why we have those two relays there? Any questions or comments? Everybody good? Okay, Tony, is everything still going good as far as the audio and the video and the PowerPoints and stuff?
Yep, everything is just fine.
Okay, sounds good. All right, team. Well, let's take a look and let's talk a little bit about some airflow considerations. Please remember, team, on every install to confirm proper airflow. And again, we always want to size our ductwork to 400 CFM per ton of total capacity. And the HMH7, because it is a modulating unit, airflow is critical. And the reason I say that is, think about it for a second. If we don't have proper airflow, what's going to happen? Let's say we have an undersized return duct, for instance, and the evaporator is getting cold inside, colder than it should be because we have low airflow. What the outdoor unit's going to do is going to perceive that as a reduction in capacity, and it's just going to start screwing its capacity back like it's supposed to. So airflow becomes very, very important, especially on modulating systems with all the sensors and stuff these things have in it. And as a quick reminder, our HMH7, it's got like 4 or 5 sensors that's going to be constantly monitoring outdoor air temperature, suction line temperature, liquid line temperature, discharge line temperature. In other words, it's monitoring and looking at the refrigeration cycle and plotting superheat and subcooling and all that, and it's looking at these numbers, and it's making intelligent decisions on where it needs to be for capacity. So if you've got low airflow inside for whatever reason, the wrong fan speed or the undersized ductwork or filthy air filter, or you cats get the idea. If you have reduced airflow inside, that evaporator in the cooling mode is going to start cooling down more than it should because you don't have the proper airflow. And the outdoor unit's just going to say, hey, it's getting cooled off inside, and I'm going to reduce my capacity. And so the last thing you want, especially when it's hot outside or humid outside, is to have your outdoor unit starting to screw back on capacity because you have improper airflow. So please check that airflow. That's, the whole lesson here is make sure that you look at your airflow and make sure you've got proper airflow. And we always recommend, using the proper tools when you're designing your duct system, a duct calculator, and so on. And finally, one of the things that we always want to make sure is to refer to Manual D, which is our airflow and duct design manual. That's kind of the standard of our residential airflow and duct design in our industry. And please remember that not only, gross airflow, but also velocities. And this comes right out of Manual D, this table, by the way, this sample table. Don't forget the velocity becomes very, very important as well, to maintain. You can have airflow, but if the air is moving too fast across that indoor coil, you're not going to have proper heat exchange as well. So please take a look at that. We're not going to beat this dead horse to death, but please remember that velocities are also important. As you dig into some of the velocity tables on Manual D, you'll see that there's going to be some recommended and some maximum velocities for both the return and the supply. As you can see some examples here, like your main trunk, your main trunk coming off your unit, recommended is 700 feet a minute velocity at 400 CFM per ton, and return is 600, and so on. So there's making sure that you're not moving the air too fast, because remember, and I'm stressing this a little bit, because please remember, on a variable speed product at ECM Motor Products, if they see an increase in static because you have a dirty filter or undersized ductwork, they're going to ramp up. And as they ramp up, what's going to happen? They're going to do everything they can to deliver the airflow, but the velocity is going to go up. So variable speed products, even though they will deliver CFM where nothing else will, you need to watch these velocities, because you don't want to exceed these velocities, because it gets noisy and you start moving air across those heat exchangers too quickly, and that can actually cause issues as well. And so please remember, Manual D, ACA Manual D does cover recommended velocities as well. One of the ones I really like to talk about, especially in Tony's area down south in Florida, is they have a lot of central returns, like in a closet and stuff like that. And so if you've got a central return with a filter grill, or if you have multiple filter grills, please note that the recommended face velocity across that filter is not to exceed 300 feet a minute velocity across the filter if you've got like a central unit with just a central filter, like in a hallway or a closet or what have you. So some airflow considerations, please consider those things when you're installing these units. It will be very important that you maintain proper airflow if you want the outdoor unit to modulate and to work properly. So with that, let's go ahead and open up the floor for any questions or comments of the program. I'm going to go ahead and turn my camera back on, and we're going to stop sharing that screen, and we'll open that floor up. Let's open the floor up for any final questions or comments before we secure for the day, and hope you enjoyed the training.
Okay, on the airflow, do you recommend a certain temperature split between supply and return, like old school, or do you have a formula to figure out what's right?
I'm hearing about a third of what you're saying. I apologize. You're not coming in real clear. Tony, were you able to hear them a little better? Or
The question is about the airflow. I'm sorry, I didn't quite pick up all of it. Could you restate that?
Okay, yeah, we've got our microphone put on now.
Well, you're on mute right now. I'm sorry. We can't hear you guys. There you
What
go.
about now, Tony?
Yep.
Okay, on airflow, old school, we just check between supply and return to 18 to 22 degrees. Do you recommend that on this, or do you have a formula? We need to.
that's an excellent. That's an excellent question. So basically, all of our products in the install guide, they'll give you airflow charts, and those airflow charts are going to be based on static pressure. And so look at your supply static and then your return static and add them up. So let's say, for instance, you have a 0.3 inches of static pressure on the supply and say 0.2 on the return. I'm just making that up. The total will be a 0.5 inches static. So based on the indoor product you have, you go to our airflow charts,
Okay.
and you correlate your speed tap or your airflow settings or your jumper settings and so on with the static pressure, and then where those points intersect on that airflow chart, that static pressure airflow chart, it'll tell you the CFM you're actually moving through that cabinet on the indoor product.
Okay.
Yeah.
Okay, so we actually need a device to be able to check static pressure.
Yeah, either what I like is just a digital manometer with the static pressure probes, or a magnehelic gauge. Now the magnehelic gauge, they're kind of cumbersome and large, and they're fun to look at and all that stuff. But anymore, guys, they typically will use like a digital manometer that'll go down to 0.001 inches of static. And I like the digital manometer also because it not only lets you check static pressure, but it's also a very versatile tool. You can check gas pressure with it. You can check static pressure with it. You can check vent pressure with it, and so on. And so a good quality digital manometer with a digital manometer with static pressure or static air pressure probes is what I recommend. Tony, you've kind of invested in some of those nicer tools recently.
Yeah.
Would you like to talk a little bit about that?
Yeah, I like the field piece instrumentation, in their digital manometers, their electrical meters, their digital gauges. They're really, in my opinion, they're a great value in cutting edge technology that's used there. Guys that started out, I started out in the trade in 1978, and Joel, similar, and it looks like you've been at it for a long time. Back in those days, the tools we had were pretty limited, and anymore it's just amazing the tools that we have to be able to evaluate the critical measurements on systems.
And fellas, let me go ahead and make a quick offer too. If you guys would like to set a little training session, what we can do is we can do like an airflow measurement overview class, half an hour to an hour long, looking at some factory airflow charts and where to take those pressure readings and all that kind of stuff. We can certainly put something like that together for you if you'd like to review that. As far as, how do I measure airflow and what does it mean and what charts do I look at and where do I get those charts and all that kind of stuff. We'll be glad to do an overview with you on that if you guys would like to overview that sometime.
That probably wouldn't be a bad idea.
Okay.
Yeah, and we've got a few minutes here. If you guys, we had allowed an hour. Do you guys have a few more minutes and we can show you some stuff, where to find some things?
Yeah, we can do a few more minutes.
Okay.
Guys, let me go ahead and stop the recording at this time. And I want to thank everybody for training with us this morning. And we'll continue with some off topic or some offline things, but let's go ahead and stop that recording at this time.
Thanks, Joel.